Welcome. Today we'll be handling a question on estimating and costing, where we are required to determine the number of dampers required to maintain an untilting mixture during concrete work. So we are mixing concrete at point A and we want to transport that concrete to point B. So we want to know the number of dampers required to surface the mixture. And we are told that the damper is carrying 0.5 meter cube. Then we are placing it at 200 meter distance. So the distance here is 200 meters. We are required to know the number of dampers that will carry out the work. Basically, when you are calculating the number of transport unit, it is given by output per hour. In our case here, output is from mixture, then carrying capacity per hour. Carrying capacity is the damper. In 1 hour, then we always add one extra unit. So already we have output per hour from the data, because we are told that the mixture output is 6 meter cube per hour. Already that one we have. Output per hour, you have 0.6 meter cube per hour. So what we are supposed to calculate is carrying capacity per hour, and then we equate to this equation to get the number of dampers. Carrying capacity per hour. So this one we just need to know the number of minutes that is required for one trip to happen. Number of minutes required to carry out one trip. So for the dampers to go to point B, place the concrete and then come back to point A. So we are given that average speed is 15 km per hour. Maneuvering at both ends is 15 minutes. Then unloading time is 0.5 minutes. This is 1.5 minutes. So traveling speed is 15 km per hour. So that is average speed of from point A to B and then B to A is 15 km per hour. We need to know the number of minutes that will be taken for the transport unit. So this one we can also equate. 15 km is requiring 60 minutes. What about 200 meters, which we can convert to kilometers, which will be 0.2 kilometers. So we can equate this as 15 kilometer, that is 0.2 kilometers multiplied by 60 over 15. This one will give us 0.8 minutes. So that is traveling at one way, and we are traveling to point A to B, then B to A. So we multiply this one by 2 to get both way, which will give us 16, that is 1.60 minutes. So we can be able to get the total minutes that is required to carry out the work, which is now maneuvering at both ends, which is 1.5. Then we have unloading 0.5, and then traveling, which is 1.6 minutes. The total of this one will give us 3.6 minutes. So the total time taken to transport 0.5 meter cube will be 3.6 minutes, and in 3.6 minutes we will transport 0.5 meter cube. But if we go to the equation, we want carrying capacity per hour. So 3.6 minutes is 0.5 meter cube. What about 60 minutes? So we'd have 60, we multiply by 0.5, then we divide by 3.6 minutes. So let us see what we get. 60 multiplied by 0.5, so this will be 30. We divide by 3.6, and this is 8.33 meter cube per hour. So in 1 hour we transport 8.33 meter cube. So we can now equate this to our equation. Number of dampers will be given by output per hour, which is 6 meter cube per hour, over 8.33 meter cube per hour, which is output carrying capacity per hour, plus 1 extra unit. So this one will give us 0.72 plus 1 equals to 1.72. So say 2 dampers. So the number of dampers required to carry out the work, there are only 2, and with that we have handled our question. Thank you very much. Join me for my next example.